This is Tao Unbound, the English language podcast of Tel Aviv University. Please welcome your host, Ido Aharoni, Tel Aviv University's graduate, member of the Board of Governors, lecturer, writer, and veteran diplomat.
Welcome to yet another episode of Tao Unbound. I'm Ido Aharoni, your host, and today it is my distinct pleasure to host Professor Liad Mudrik.
Hi.
Thank you so much for taking the time to visit with us here in the studio. It's not every day that we get a media star to come to our studio.
I wouldn't go as far, but thank you. Thank you for inviting me. It's my pleasure.
But you really transitioned into the world of academics, and you did it exceedingly well, right?
Thank you.
Let me just share with our viewers and our listeners your really incredible accomplishments. Did you know that she has 2 PhDs, not 1, 2? That's incredible. So first of all, you were recruited to the interdisciplinary program for outstanding students. I'd like to know more about that. It sounds like very prestigious. Then I mentioned she has 2 PhD degrees in cognitive neuroscience from Tel Aviv U and Hebrew U, and in philosophy from Tel Aviv U. And the latter, her second PhD, was awarded with the Robert J. Glushko Prize for Outstanding Dissertations in Cognitive Science, which is what we're going to talk about. It's a little abstract, but we'll try to do our best to make it accessible to you. She then continued to work as a postdoctoral fellow at the Division of Biology at the California Institute of Technology, known as Caltech, and joined the School of Psychological Sciences as a faculty member in 2015. She's a member of the Israeli Young Academy of Sciences.
Not anymore, because I'm not young enough. I've been young for 4 years, but now I'm not considered young anymore.
All right. So as far as we are concerned, you're still very young. Wow. You accomplished a lot in your short life. And so we are going to talk today about your work, which, if I understand correctly, is trying to find out more about cognition, consciousness, awareness. Where is it happening in our brain?
Yeah.
And how, right? This is the work. And so, but first tell us about your background.
Where do I start? So you probably you kind of said everything already. I was actually born in Bnei Brak, which is an ultra-Orthodox town in Israel. And when I was in the second grade, we moved to Kfar Saba, which is where I lived most of my life, pending a few years outside of that city. And I'm married. I have 3 kids.
And
what else do you want to know?
when did you discover that you're interested in neuroscience?
So it was an interesting path, because I started, as you said, in the interdisciplinary program named after Adi Lautman, and for me it was like an intellectual candy bar in a way, or not candy bar, candy store, because the students in this program are allowed to take any class they want from any faculty. So I created this mix with, a little of organic chemistry and some theater and some history and some math and this unique and some philosophy and some biology. And the more classes I took, the more it became clear to me that the thing that interests me most is the mind-body problem, which I think in current days is actually the brain consciousness problem. So trying to understand how the brain, an amazing machine, how does it manufacture or create our conscious experiences? And it's super interesting because they feel very different. Our conscious experiences, the blueness of the sky. I always like to give the example of the taste of chocolate because I really like chocolate. The sound of my voice. These are all qualitative experiences. They feel like something, and they feel mental. So they feel as if they are not physical in a way. But I think that they are completely physical, and that the brain is what makes us conscious. And so the question is how? And the question is interesting both philosophically, because that, again, pertains to what is our world made of? Is it made of only material stuff, only physical stuff, or maybe more, as some people used to think or still think, but also very important scientifically. because it tells us who we are, why we behave the way we behave, what type of processes are conscious and what type of processes actually occur unconsciously. And it could also take us into realms of how do we know which system is conscious and which is not, which is very important ethically.
Now, you got a lot of exposure in the media because of your work. And one of the things that I was able to read in preparation for this episode is this really comprehensive interview that the Haaretz magazine did with you a while ago, and in which they talk about two fundamentally different approaches to the subject matter that are not necessarily contradictory. Can you elaborate on that?
So I think you're referring to two theories of consciousness and to a project that I am co-leading together with Michael Pitts and Lucia Meloni. And the idea there was we have, in the field of consciousness, we have many theories. And they try to explain, again, the relations between neural activity and conscious experiences. And two of these theories that have received quite a lot of attention provide indeed different accounts. Some of these accounts are contradictory, some are not, but they are very, very different because one, first even anatomically, so one of them thinks that consciousness is observed by frontal areas in the brain, while the other is more focused on posterior areas in the brain that are more sensory. But they're also very different in the temporal aspect of how the activity should look like over time. There are different predictions made by these two theories that try to explain consciousness differently.
Now, why is it important? What are the applications of it in everyday life?
So it's actually interesting because when I started, I was young and vain, like a bit of a hubris was into me, I think. And I used to take pride in saying that we want to solve the problem only for solving the problem. Like there are no practical implications. It's only to kind of find the truth. But now that I'm definitely not wiser, but definitely am older, I do realize that was completely stupid of me, in the sense that now I understand that that there are practical implications, and B, that practical science is so important because it goes beyond basic science in the sense that you could actually make a difference in the world. So I no longer hold this idealistic approach about science. And I think that specifically with respect to consciousness, if we know how consciousness works in the brain and what are the necessary and sufficient for consciousness in humans, then we can ask which animals are conscious. We can understand better clinical cases with disorders of consciousness where you have a non-responsive patient, but you really want to know, does that patient experience the world? Are they conscious of their surroundings? And we have to have a tool in order to know that. It would allow us to know at what stage fetuses are conscious. And it would also allow us, especially these days, to understand whether AI, artificial intelligence systems, are they conscious? And all of these questions have highly important societal implications and ethical implications. So being able to provide informed answers rather than just guesses to these questions, I think is a huge contribution of our field.
Now, tell us a little bit more about the practice of conducting research, because what you're talking about sounds so abstract. And I read in the paper that one of the postdoctorants in your lab actually conducted a study that included hundreds and hundreds and hundreds of tests. So tell us a little bit about the mechanics of it.
Yeah.
How do you do it? How do you examine that?
So this is actually a PhD student in the lab, Ido Aharoni, but he is definitely as smart as a postdoc student. And he did an enormous project where indeed he analyzed more than 400 experiments that interpreted their findings in light of different theories of consciousness. And he tried to understand how can that be that we are trying to explain the same thing, but we have different theories that give us completely different answers and different accounts, even with respect to brain areas, as I said before. And what he was able to show was that we can predict just by the methods used by the experimenters, which theory is about to be supported. So again, he took some kind of classifier. he fed the classifier with all the methodological choices of the experimenters. For example, what was the paradigm? Which sample was used? So what was the population? Did participants report on their conscious experiences or not? And then asked the classifier to predict which theory is about to be supported given these experimental choices. The classifier knows nothing about the results of the experiment, but it was still able to predict in 80% accuracy. Now, that means that the way we construct our experiments to begin with, in a way, presumes the answer that we are about to get. And I think that's important. It's an important lesson, not only for consciousness researchers, but also throughout. I'm willing to bet that the same result would have been found, or at least to some extent, also in other fields.
So what you're saying is that unknowingly we are biased by the way we design the study.
Yeah, in a way we are.
And what are the recommended methodologies to avoid that?
So one way we try to avoid that, and I'm now going back to that project with Lucia Meloni and Michael Pitts, and this is the Cogitate Consortium. So the way we worked there is we actually worked with the proponents of the two theories that we tested, global neuronal workspace and integrated information theory. We sat together and tried to devise experiments that would test the theories with the theory adversaries themselves. And then what happens is that each side injects their own biases and pushes the other side, and that increases the chances of creating an experiment that would be more neutral and less theory biased. And this idea of trying to work together in order to find a way to arbitrate between the theories, or at least highlight the weaknesses of the theories, was an idea that was suggested in psychology by Daniel Kahneman, who recently died. And we've been very privileged because he also kind of mentored us in the process and told us how to go about it, because it wasn't easy.
So that's interesting that you mentioned Daniel Kahneman, because you were trained, I'm assuming, early on in the interdisciplinary approach, meaning it's not enough just to study psychology.
Yeah.
It's not enough just to study medicine. We have to be able to cross over from one discipline to another. And you mentioned Daniel Kahneman, whose contribution, actually, he won the Nobel, I think, in economics, right? Although his work was in social psychology.
Correct.
So what disciplines you're crossing on your way, on your journey? So psychology, you're part of psychology, right?
Yeah.
What else? Neuroscience?
Psychology, neuroscience, philosophy, biology to some extent. We have in the field of consciousness studies, we have computer scientists. I have some in my lab. We have physicists. I think it's really an interdisciplinary endeavor, because the type of question that we are asking touches upon so many key questions in these different disciplines, and the contributions that people can bring in, I think, are highly important. And I generally advocate for taking an interdisciplinary approach, because I think it opens your mind. But specifically when studying questions like consciousness and free will, which are the topics that I engage with, I think it's even more important.
What, in your view, are the biggest ethical questions that the implications and the applications of your work could present in the future? Because you talked about we may have the ability to know if a fetus has any level of consciousness, or a person who is in coma. So what would you say? Because I'm assuming that some of our viewers and listeners will be interested in the ethical aspects of it.
So many philosophers have written about the very close relations between consciousness and morality. We tend to assume that if a creature is conscious, then it is entitled to some moral status, and we need to behave differently or conduct ourselves differently with that creature because of its ability to have conscious experiences. And even if you think about the way our laws are constructed today, and I remember hearing Yuval Noah Harari speak about that in the past, he said, in the past, the validity of the law was based on either religion or on the king saying that that's the law and that's it. But today we have the discussion is all about rights, and specifically about the right not to suffer and not to have our feelings hurt in one way or another. And of course, there are also many other ways by which we define our laws, but we cannot deny that the consciousness discourse is highly important when we make decisions. So we want to know, we spoke about fetuses, and there is, of course, a very lively and heated debate about abortions. So if we are able to determine the stage at which a fetus becomes conscious, it might inform our decisions about the stages by which it is allowed or not allowed to have abortions. I'm not getting into this discussion, but I'm saying that when you have more information, you can make more informed decisions. Think about Westworld, right? So in Westworld, you have these robots that are super sophisticated, and people there allow themselves to behave quite viciously with these robots. But when they become conscious, something changes. So it's important for us to know when a system is conscious in order to know how to behave towards that system.
And which is a beautiful segue to move to the subject that you slightly touched upon of AI, which I call machine learning.
Mm-hmm.
So the question at hand, philosophically and practically, is can a machine, a computer, learn to develop or at least to behave as if they have conscience, right?
Yeah.
This is consciousness.
Yes.
That's the question.
So we are actually we want to go a step further and ask, can they actually have experiences? Not only behave as if they have experiences, but can they consciously experience?
That's very interesting. I once heard a talk by an Israeli professor, I think he was at MIT or Cornell, who was looking at robotics.
Mm-hmm.
He was giving robots very basic robots, simple assignments, and then he would take one part out and see if they can develop the ability to compensate for that part that he took out, like he would take out a leg. And what he discovered is that they could eventually, after many, many tests. His name was Hod Lipson.
Mm-hmm.
I don't know if you're familiar with him.
Yeah, I met with him.
And so
I think he's in New York, though. I don't know.
he may be in New York now. But when I heard him in Canada, actually.
Okay.
It was at a conference in Canada. But I was very impressed. This was 2009, when he already spoke about that machines can actually develop a compensation mechanism without any external intervention, which leads me to the work that you're describing. What if we will discover that machines can actually develop what you're describing?
Yeah, so for sure we would have to behave differently towards them, I think. And there was this big, scandal with Blake Lemoine, who claimed that Lambda, the AI system he was interacting with, is sentient. Ended up towards him being fired, if I remember correctly. And I think that we now live in quite an incredible time, in the sense that our world is changing. Like AI is going to become more and more prominent in our world, and it will be able to do extraordinary things that we typically, or at least previously, thought that are uniquely human, uniquely conscious. And now we see that they don't have to be necessarily. And it would be very important for us to understand to what extent are these AI systems capable of having experiences. So to feel things, to not only be able to speak, as you said, as if they are conscious, but also to actually have mental states that feel like something. And in our attempt to try and define, so the big question is, how would we know, right? How would we be able to differentiate between an AI system that is conscious and another that only speaks as if it is conscious? And I'll just say as a side note that, some of these AI systems, when you ask them, are you conscious? They say, yes, I am, like the one who was conversating with Lemoine. But then if you ask them, are you not conscious? Then they say, yes, I am not conscious. I'm only a machine. So they are prompted to give you sometimes the answers that you want to hear. I don't think that any of the systems currently are conscious. But how would we know if they are? So in a joint work with philosophers and computer scientists and neuroscientists and psychologists led by Robert Long and Patrick Batlin, what we have done was to take theories of consciousness that assign specific functions to consciousness based on human work, mostly, but also as a bit of animal work, and then say, what are these critical functions? Let's use them as markers. And if we have an AI system that shows these markers, and I can give some examples, then we would have a more, again, informed basis to think that it at least has a chance of being conscious. So our credence in the ability of this system to be conscious, or to actually, that it is conscious, is now higher thanks to the fact that it meets these markers. So what are these markers? For example, if you take the global neuronal workspace theory, it should have some kind of an attention mechanism that allows it to select information from everything that is being processed in parallel, taken into some executive central system. Or if you think about another theory, recurrent processing theory, we would like to see that it is able to have perceptual organization, and that not all of its connections are feed forward, but there are also some feedback connections that allow it to learn and change itself. So based on the different theories, we extracted these key markers, and then basically you can go to any AI system and ask, how many markers is this system implementing?
And can you detect those markers?
So we can detect those markers. I should say again that this is taking, I'm going to say now a complicated term, but we will explain what it means, computational functionalism as a working assumption. And according to this assumption, basically, if you have a system that is functionally equivalent to a conscious system, like a human, and that it's functionally equivalent not only in the way it behaves, but also in the way it computes, so the way it is built, its architecture, and the way it works, then some people in the group would say that it is conscious. I'm still a bit more skeptical, and I say then the chances of it being conscious are higher than of a system that is not computationally and functionally equivalent to us.
To what degree would you say that the people that designed those computational structures were influenced by the design of the human brain?
So in many ways they have been. I'm not a computer scientist, but we all know that one of the big leaps in AI was the ability to be inspired by neural networks and to try to mimic the way they work. But I should say, we're seeing incredible stuff being done by AI today. I still keep going back to the basics and being amazed by the human brain. Like the things that our brain can do with very little energy. We don't provide it that much energy throughout the day, and with very little space that it captures, and also with relatively little learning set. So that GPT had to be exposed to the entire text on the internet in order to be able to speak the way it does. We, think about humans, think about children. Within the first year or two, they are exposed to language, but to a relatively limited amount of language. And still, this magic happens, and we learn to speak, and we learn to behave, and we learn to make decisions. And I find this completely marvelous, and think that this is one of the most important things to understand.
Now, let's talk about something that I think the parents to young children that we have listening to us right now will be very interested in. So there's a series of books that just came out recently, most notably The Anxious Generation by Jonathan Haidt, whom I greatly admire from New York University as a social psychologist. And the main argument is that there is a phenomenon described as the great rewiring of the brain of children, adolescents and children, way too early, before they're fully developed, by social media platforms in such a way that would really endanger society and civilization. There are many, many examples which I will not go into why this is so dangerous. And the question, do you see in your work any insight that could help societies to defend themselves from the very freedoms of liberties that they grant children with access to those little devices that give them gateway to the whole world?
Yeah. So I haven't studied the effect of screen exposure or social media exposure on the brain. There are many researchers who focus on that. So I cannot give you an expert answer, but I can say what I think as a mother and as someone who read quite a bit about this topic, just, being a mother and wanting to understand how I should, treat my children and with screen time and so on. From what I've learned, it seems that there are several studies that found effects on the brain due to screen exposure. And those effects could be manifested in a thicker volume of the frontal cortex. With greater screen exposure, they could be manifested in less efficient connectivity between areas in the brain. And I should say there are also studies who didn't find these effects. But my kind of approach is, when in doubt, be on the more cautious side. So I think that we as parents have the responsibility of trying to limit as much as we can, and it's very, very difficult in the era when we live in. Try to limit screen exposure. And I think you alluded to social media. Again, this is not based on my own research, but as a worried and concerned citizen, I think one of the most dangerous things in social media is that it makes us more limited to our own way of thinking. It exposes us less and less to other views, and it makes us less able to understand even other views. And when you're bound to be within your own silo, I think that's one of the most dangerous things for society at large. So I think it's our responsibility, and this is one of the things we try to teach also our students, right? Critical thinking. Don't accept things just because someone said that to you, or because you saw them on WhatsApp or on Twitter or wherever you get your news from. Be critical. Try to always expose yourself to other opinions, and try to avoid these biases that we are all subjected to as much as you can. And I would maybe add one more thing. There was one work that we've done with philosophers about free will and about the way these biases limit our freedom. And one of the conclusions we got from that work is that, and it's not new, but it's nice to say it again, that knowledge is power in that respect. And we've heard it from philosophers in the past. So the more you learn about your own biases, the better you are in becoming freer, in exercising your freedom to make a decision.
Right. And in many ways, and I think it's counterintuitive, the digital revolution has taken us back to the tribal form of society. Only this time, these are digital tribes. It's digital tribalism.
Yeah.
And so a lot of people find it almost impossible to get out of the position of their group, of their echo chamber.
Yeah.
And that's the danger that you're describing, which I couldn't agree more. Let's talk a little bit about the future. So you've been doing extremely well. We just heard about all the amazing work that you're doing. It really sounds like science fiction, really, especially the part about machines. Having real experiences.
I'm not developing them. I'm just trying to understand what would it take for us to know.
Right, yeah. And so the question is, what are the next steps for you scientifically, and how can we as a community, and this podcast really is about celebrating the talent of our community, and your talent of our community. How can we as a community help you in your work?
So I think that I can describe the future venues of our work, and maybe if someone finds it interesting, I'm more than happy to discuss this further and think about ways by which we can promote it together. But the things that we are now very much looking into are the following. So first, I already spoke about tests for consciousness. So how can we devise tests that would allow us to detect consciousness in different species, in different systems, in different creatures. And this is something that we are, devoting quite a lot of time and effort into. Another is to explore the realms of unconscious processes. So to what extent can you read, detect emotions, act based on unconsciously processed information. And the main hypothesis that we are testing now in the lab is that individuals might differ in the extent by which they are affected by such unconscious information. So we are looking for individual differences, and we wonder whether this might be a human trait that we've been overlooking. So that's another venue. Another thing that we are very much interested in is finding more ecological ways to study consciousness. And now when I say ecological, I don't refer to the, climate change, but consciousness has been studied in highly artificial paradigm. So we have our very complicated ways to make you not see a stimulus, for example. I could present it really quickly so you wouldn't see it. And then we can ask, what is the difference in your brain activity between the time where you saw it and the time where you didn't? But these are all edge cases where we push our participants to the limits. What we are more interested in is unconscious and conscious processes as they take place in real life. So we use virtual reality and extended reality in order to mimic real life, everyday experiences, conscious and unconscious processes, and try to find the neural differences in these more ecological setups. And this is something that we are very excited about. It's highly complicated to do, but we find that also very interesting. So I think exploring these new ways to study consciousness, exploring the limits of unconscious processing, trying to understand which theory explains consciousness better, and at the same time looking for tests for consciousness. These are the horizons for my lab, at least in the next few years.
Sounds like you have a full agenda for the future, and we can only express our gratitude for you taking the time to be here with us and really share with us the incredible work that you're doing.
My pleasure. Thank you.
And if we did not know why you are considered to be a superstar, now we do know.
I feel that I'm not worthy for all these compliments, but thank you very much.
But we thank you. We thank you, and hopefully we'll get to talk to you again soon. And to our viewers and listeners back home, goodbye from Tel Aviv until our next episode.